to the next session. I'm happy to be here and to talk with you about history and fundamentals and maybe the future of cloud native. So, my name is Benjamin. You can find me also on Twitter. I work for a consultancy in Germany and founded there 2 offices, and we are currently 16 engineers. Besides that, I had the pleasure to found a Java user group, as well as a few other user groups, and help at several conferences, JavaLand, Cloudland, and MicroExchange, happening in various places in Germany. I was asked to write an article about cloud native and for a magazine called RecStack, and now I want to talk a bit about it and bring light into this topic. So we will go through the history in the beginning, then we will talk about what are the drivers for cloud native, why do we do this, why did it occur, what are currently established principles, and how can we design a cloud native ready application. And later on we want to look a bit into what are like the current tools on the market. So, the history, what we could observe in the past was like over the time, cloud native as a term has been occurred already in scientific papers before it was like visible in the industry, and it steadily like raised in awareness. It was put into contrast to classical distributed systems, for example, like SOA. In the industry in 2006, like maybe as a nice point in time, we can see that Amazon S3 buckets were launched, and at that time, a lot of like this hybrid cloud computing terms, public, private cloud, infrastructure as code, platform as a service, and software as a service terms, they were pushed, right? So it was very, very obvious. In 2011, there was a publication by Peter Mell and Timothy Kranz, and they were writing out a glossary called the NIST definition of cloud computing, and many terms were presented, and it was already talked a lot about distributed systems and cloud computing, but in 2011, which is like roughly 10 years ago, there was not an establishment, at least from the academia world, of the term cloud native yet. Just in 2012, the term finally got really spread, and there was a first draft presented at the Cloud Native Engineering Conference, and it contained already some patterns, like for example the CUP theorem, where you can just achieve the 2 of consistency, availability, and partition tolerance. In 2015, the term then finally spread also in the Google search results, and it was appearing as a logical evolution that was like driven by microservices. Then in 2017, there was finally a paper reviewing 10 years of cloud native computing. So many terms that were like already presented over and over again, they were like condensed, and Kratzke and Quint, they wanted to outline what was the meaning behind them. They came up with the first definition that we had of a cloud native application. In their terms, a cloud native application is a distributed, elastic, and horizontal scalable system composed of services or microservices, which isolates the state in a minimum of stateful components the application and each self-contained deployment unit of that application is designed according to cloud-focused design patterns operate on a self-service elastic platform. So what did they mean by that? So they had several things already in mind. For example, they said, like, we want with that, not just by giving out this definition, also cover a lot of other ideas behind it. Like one principle was to say, like, the ideal attributes should apply so that we have an isolated state, that the CNA is distributed in nature, it's elastic, so horizontal, scalable, automated in management, and of course, loosely coupled. They also said the motivation is speed, safety, scale, and client diversity. So that you have not just like web application, but also mobile and different platforms there, of course, with tablets and so on. From the definition point, elasticity means for them that the workload needs, like, in the provisioning of systems, you need to be able to scale it at every moment and to align it to the needs of the business. So if a heavy load comes in, your system should just spin up. A very good example these days is, of course, like serverless technology or no-code platforms, where the background is handling it very efficiently. And also, in terms of scalability, this means, like, also not just like in the background that infrastructure is scalable, but also that your system, when it is growing and that when the business is evolving, that you need to take care of a structural approach how to scale your system. For that, they thought, like, the term of microservices might be really good, which means that the business requirements are, like, met in, like, condensed small pieces, and an idea how to design that stuff is like using domain-driven design. Also, they mentioned that the deployment units should align to the 5 principles for containers, which were driven by the Open Container Initiative. And also, we should use as little state as possible. So to have every component, like, using like as little state as possible, and just like have very brief points in your system where you save state. So elasticity can be, of course, like driven by platforms. In that terms, they considered already like Kubernetes, Swarm, and OpenShift. Other terms that were defined in the paper were DevOps. Under that, they understood build, test, and run the system, and like softwareization shift, which means like the infrastructure and networks, they are like more and more like converging into also software solution world, and you need to be aware of also infrastructure code. Yeah. State isolation I already mentioned, like keep it at a minimum, and loose coupling means that when you have 2 systems and they talk to each other, try to do it, for example, asynchronously, like using AMQP. So how did they find out about this, and why did Cloud Native in general emerge from the business side? I want to talk briefly about the bathtub curve and how industrialization has like led us into a state of a highly dynamic market. So when we look into the past, really long time ago in the pre-industrial area, there was just very few craftsmen out there, and there were unsaturated markets, but everything was very expensive to manufacture, which means, like, to conquer the market and win, you needed to like align with each customer individually, and you produced just for local markets usually with a very high customization, and production was very expensive in general for all goods. So when you wanted to have a good running business, the key was you need to master your craft. So this means we already had learning passes for different types of like jobs. Everything was tailor-made. But it took a long time to manufacture, of course. Then finally, in the industrial area, we found patterns how to like automate stuff, make everything very cost efficient and scalable. So the markets were unsaturated. So what you need to do to succeed is just like produce as much as you can at very low cost. And then you could be sure that you could become a market leader. So if you think about the first cars that arrived, like Ford Model T, we had a nice chain in production, how everything was like put together, and everybody, of course, didn't have a car. So now, just by giving out the first implementation of a vehicle, we could be sure that the market will just buy everything that we give out. So the markets were really unsaturated and was really easy, and there was basically no competition. And we just needed to like go on and make it simpler and simpler and simpler in the production. Now the markets, of course, they are changing, and you can imagine there have been a lot of manufacturing and a lot of different types, and now it's more about finding the right niches, right? So everybody maybe already have an item in a certain field, like a mobile phone or car, and now it's just like what additional value can another like technology or another type of product present to you. So in that area, what you need to do is like act as fastly as possible to the changing market. And what was now the driver was like just the adaptation rate of a business. The markets are now global, and the key here to success is the continuous measurement of what the customer wants and to communicate with it. So when we look at it in the industrial area, it was more about cost efficiency, scalability, reliability, and stability, and efficiency of scalability. And these days, in the post-industrial world, it's much more about cycle times, adaptability, flexibility, resilience, and effectiveness. And speed are now the main drivers. When we look at IT and try to have a timeline of it, we see that in the 60s there was the software crisis, in the 70s a lot of our principles have emerged, and it's always like there was new technology coming out. We had the internet, mobile, IoT devices, and it's getting more and more complex. And the complexity is not just like pricing in terms of IT, but also in terms of what are we supporting in terms of like the markets and the business. Like in the past, we just had really selective support for very few things with IT, and these days it's going more into everything is IT, like it's a holistic approach. So we are, of course, on the top right. A lot of things that we learn also at university, they are still based on the software engineering principles that we had in the past. And there's now this gap that we need to try to close. And the point is, at that time, when we established all these principles, the business world was completely different than it is now. Now we need to cover a lot more different parts, and this means traditional approaches of IT, they are of course counterproductive. Besides what I mentioned in post-industrialism, we also have a lot of digitalization and digitization going on. So not just that we have businesses that we try to help and support with IT, but also IT has become a product itself. Also by having a lot of digital conversations, we have social media, we have contextual computing, and this is also enforcing a lot of change onto our IT landscape. Besides that, we can see that IT also offers the possibility to have a disruption. So if you think about classical business approaches, we know that Netflix, for example, took over large parts of the video market, or also other streaming services, of course, as well. And the whole landscape is changing, or Uber for taxis, and all these classical examples that we are now aware of. So what should be the new goal? The new goal of IT needs to be quick, we need to be flexible, effective, and also efficient, reliable, and try to improve continuously. What does this mean for us? How does the organization shift happen, right? So in the past, we have maybe worked in such silos. So I have been part also of teams where we just took care of certain business capabilities, and then we handed everything over, maybe also to a release automation team in the middle, and then to an operations team. And there was this value chain going from left to right, and also our release cycles at that time, they were maybe on a yearly basis, half-year basis, or quarter-yearly basis. Through DevOps, we had that shift, which meant that every team was now more or less cross-functional, which means they needed to take care of the operations part. These days, also security, of course, plays a big role. So it's also going into DevSecOps land, of course, but this is just a logical extension. Maybe we still have a supporting platform team, so they could help the teams in building pipelines or setting up their systems, but in general, you are taking care of the whole vertical. So for the engineers, this means we now need to implement DevOps. We need to have cross-functional teams that are organized by business capabilities. For that reason, the teams, they need to be autonomous. So they have end-to-end responsibility. There is a decentralized control over that autonomous teams, and they are driven by the outcome. At best, they are looking on their own into the market, measuring what's going on, and then try to implement it and try to achieve the highest business value there is. This is true for most teams. When you have big applications where you work with end customers, you can go that route. And the point is that it's not more about being a cost center as IT, but more being a profit center. So you go beyond budgeting. And to get that, that feeling for the market, you need that big feedback loops, and therefore you need a continuous flow of features. The people, they need to have a really big T-shape, not like not that dense as in the past, but have a broad set of like knowledge, not just like front end, back end, and maybe like production, but also in terms of like product business. And therefore you need a lot of curious people. Luckily, we can automate and outsource these days a lot of the operations into the cloud with containers, and we have still the goal to master all the different parts of like engineering to have the possibility to continuously deliver. So, what are principles that have been established in cloud native? In 2012, when we look in now the industry sector again, there has been the 12-factor app manifesto by Heroku, not present these days anymore, just now, and they shut down. And they already like observed many things when they built their cloud platform. For example, that you have just one code base for each service and you deploy that many times. You need to have like explicit declaration of isolated dependencies. There is maybe, besides like your containers, there is a central place to store your configurations. You have backing services. You have that idea of build, release, and run. And the processes should be stateless. Also about exporting ports, make it possible to bind other services. They took care of all that things. And you can read that on the website in detail. But also there is a nice book, and it is looking what's the state of the 12-factor app today. And when we look here, we see that it's now more things. So, for example, telemetry data also has become more and more visible. So we need to know what's going on, and we have established a lot of standards in that regard. For example, open telemetry. Another good way to inform ourselves is the microservices patterns. A website brought up by Chris Richardson, where he was like looking into depth what is like happening. So what is, for example, there in terms of like decomposition, when we want to split a service, when we want to have subdomains, how do we proceed there? When we want to refactor a service, what is there for possibility, and all that things you can look up here. So also not just like individual people or like cloud providers came up with ideas how to like structure stuff, but also like tool manufacturers. Red Hat, for example, they brought out a nice paper, and they talked about how a container should be in an ideal condition. So, for example, the image is always like immutable, so that you can still, like when you run it in dev, test, and production, it should behave the same. Then we need implementations for observability into the container to see if it's ready, if it's healthy, what's its liveliness, like is it running or not. and also provide other metrics, and we need implementations for that. For example, in Spring, we have the actuator pattern to get along with that. And other terms that they wanted to establish, or what they thought is helpful, is a defined conformance lifecycle. So what's happening when? That a service should be always disposable, so we are not relying on just one instance, but we can throw away containers all the time, and just they are just starting really quick, and they have when they were brought down, that it's like a clean shutdown and there is nothing left. So this is something that our tools need to take care of. As an engineer, we can take care of that. There's just a single concern that is running within an individual deployment unit. And the deployment unit can be more than one container, because there might be a sidecar container taking care of cross-cutting concerns, for example. And all that things, this is what they observed, right? And you can read about this paper from Bill when you go to the link in detail. Besides that, we have consultancies that also tried to go into our direction of cloud native, and they were talking about the independent systems architecture and also self-contained systems. Difference between a microservice and a self-contained system basically is that you cut through the complete stack. So when you have a website that is presented like a shop, you see also that several parts on a website, they are from different services, and so each part is self-contained. It could also be like that a whole page is coming from a service, like front and back end and infrastructure, and when you go to another page where you route it, that it's coming from a different service. In terms of architecture, what you've seen arising is like new types, how we can create software. Like not by having these big approaches where we like make upfront designs and write a lot of documentation, but have lightweight approaches appearing. That one of Alberto Brandolini's approaches have been really popular, which is event storming. I will go into detail in the next slides. And this, in conjunction with domain-driven design, with strategic design that is more like displaying the interaction between services, and tactical design, which is more going into the depth of each service, like how is the service built up. So they were appearing, and I want to outline how we had established the process, how to build our structurable, scalable cloud-native application. So when we thought about getting rid of our monolith in an e-commerce land, right? We had different ideas how to proceed. So we could go, of course, from as a brownfield approach where we separate certain concerns and try to come up with individual services. But the pain point here is that you still have this big chunk that is not really elastic. It's not really scalable, and then around that you have a completely different type of architecture. Another idea is, of course, going for greenfield, and when you go into that direction, it makes sense to have an event storming session up front. So in that regard, you invite all the stakeholders, like the domain experts, product owners, some architects, and maybe even some users into a big room. You hand them out a lot of sticky notes. For example, orange sticky notes in the first iteration, and you give them a task for 5 to 10 minutes to write down everything that is happening within the system. And then you ask the first person to come forward and pin the sticky note to that endless white wall. And maybe the first person just has like 5 notes, and they're written in the past. For example, when you are in e-commerce, it could be like, product is shown on landing page, product is selected on the product detail page, product is added to cart, and so on. Like you go through the process of your whole system, and then the next person comes to the front, and they're also adding like their post-its. And you try to find within that landscape a timeline. So everybody is maybe discussing in front of the white wall, or of course it could also be made like with digital whiteboards, Miro or Mural, and how each event aligns to the holistic process. And you try to find maybe pivotal events that are like more important, like key events than others, like where there is more a shift, and so that you can align a bit better. And you try, of course, in like a cleanup phase to get rid of all duplicates. What you also try to do is like establish a nice vocabulary, a ubiquitous language, so that it's not sometimes like an item is added to the cart, but sometimes there's a product added to the cart, and then you say like, no, let's like find a general agreement and come up next to it with a glossary, so that we are just using the same words for everything. And as a facilitator, it's also very important, like to get rid of all technical terms. So there should not be any like architecture terms in there that are not necessary for the business. In a second iteration, when you do event storming, you try to take care of the commands, and the commands, they are like triggering sometimes also several events. So when you add a product to the cart, it could also be shown in a mini cart, or it could be that there might be an animation that you want to have. So it's getting more and more structure. Also, like in that iteration, you also hand out this like sticky notes to all the people to think about the commands. So what is triggering everything that might have happened in a system. The next point is to find what's the interacted part here, what's the interacted data. And this is so-called entities or aggregates. And now you already have like a nice presentation of your whole system. And why do we outline these aggregates? Because you want to inspect them. So if you think about a product, so a product in an e-commerce system, in the beginning, it could be on the landing page. And on the landing page, it's just like the price, it's maybe a picture, and it's a title. When we go to a product detail page, it's already changing. So the structure, the attributes are changing. So there's maybe a description, then there's a warranty label, there's colors, maybe there's sizes, so there's different variations that you could have. But when we go to the next step, where it's just like the checkout, then it's more about in the background, not showing to the user, where is the product stored, so what warehouse, where can we get it? For example, when it's a physical item, right? Or if it's a digital item, where it's a download and so on, right? So what we see is that within that aggregates, the domain model, so the attributes are changing, and this means for us that this is the border. So we now know that the product here, even though it's the same name, the product here and here, it's not the same. And this is how we find out where is the cohesion. It's very logical and really efficient to come up now with this like bounded contexts for a service or for for microservices. So, and then the last part that you just need to do is like think about what's happening within that certain area where you have that type of aggregates to come up with a nice description, and then you already have your vertical or subdomain within your system. The last thing you need to do in event storming is check if like all use cases and stories, if they are shown within what you just modeled. So there could be a mobile client in an e-commerce system that have maybe a different route, a faster route. It could be that you have like advertisements where you go to special landing pages when you click it as a user. And there could be like additional stuff happening. So make sure there that all narratives and stories and user are like met. That you have all the user journeys that you want. And in this phase, you also check again that it's still a common language for everyone. So how many minutes do we have left? Didn't see the timer. Okay, yeah. So what we see here now is, so we have done that process of event storming, and we found our like verticals, and within that verticals now we have all our like services aligned, for example the microservices, and we still have some part of platform infrastructure, for example authentication, that could be a horizontal, and then it really it is about you, how you want to have it. If you have a self-contained system, like all these like parts, they will also take care of the front end. And if you are more going for having the front end separated in a different structural approach, you have like a horizontal for all the front end microservices. In that case, for the e-commerce system, it was that you could spin up like 170,000 instances of shops, and you had according like millions of users. So it was a really large-scale system in the end. And therefore, we needed to create instances also for the shop administration. So when you go deeper now, so you have all the services that you have structurally separated nicely. Now you need to think how they interact with each other. We heard from academia, it's always about loose coupling. And of course, this is not the whole truth. When we look into domain-driven design, we see that there is the context map patterns, which describe the interaction between the services. So we have a few that are going into the area of upstream patterns, then we have in-between patterns and downstream patterns. And I want to go quickly through them. It's the thing is, it's always like that you have a model that is flowing from your downstream system, or from your upstream system, sorry, to your downstream system. So open host service is really like one of our most natural ways of dealing with a lot of stuff in software engineering, which means we have a system that's just exposing an API. So for example, it could be SOAP or REST. It's really easy to implement, and it's usually done when you have like a one-to-many relationship. So everybody can subscribe to the service and get information from it. Here is just an implementation example. So we have a post, a get and delete, for example. Another option that is described is like event publisher, which just means that you're giving out messages. It could also be feeds, like an atom feed. And the nice thing about it is now you have an asynchronous connection between the services. So in that regard, you publish messages. They have a certain key and a certain payload. Yeah. And for that, you of course also need event publisher. In our e-commerce systems, was like really common. Like if we had images that were uploaded, we just distributed events like, look, there's been a shop image created event. And what you see here is we added the type, it's like command or event in the back, because in English sometimes like the past tense could be the same as the present tense, just to make it a bit clearer. And then you also have the systematic, like from where it's coming, like it's coming from the shop service, and what's the aggregate. The aggregate is the image, and what has happened with the image has been created. Another like pattern that you could use is customer and supplier. In that term, like the downstream system, which is handled by a different team, can give out certain descriptions, how they, what they need, right? So they can give out, for example, a contract, and the other system, the upstream system, now needs to implement it. They can say, like really orderly, like, no, we don't want to offer this because we already have like other like endpoints that we could use, or we are producing already these events. But in general, this means like there is a certain like one-on-one connection between two systems. So then it's very useful to have like this pattern. An implementation example that we used is like coming up with a contract broker in Spring, which is called Pact, and then you can go for consumer-driven contracts. And the nice thing then is if you if the team of the upstream system wants to implement it, they already get a test case and it's right, and they just implement against this test case, and then you can make sure that the downstream system is getting everything that the team wanted. Another pattern is conformist, so then there is no negotiation between the two teams, which means the upstream system just hands out everything, and the other services, they need to align to it. So there's no translation of the model, and you don't have veto rights. Example is, for example, how an event here is created when you want to spin up a new entity of a shop, which is called site in our regard. So there is no negotiation about it. This is just how it's done, and the others need to align to it. Sometimes the models, they might change. So if you have like a third-party integration, they might use similar terms than you are using in your system, and then you need this kind of anti-corruption layer. So the external model, for example, for the availability in a Google shop is completely different than the internal description of availability in our e-commerce system, and then you have like a mapping here, how you say like in stock and low stock. They are now the same, like within the world of, for example, Google shops, right, or Amazon shops. So when you have like a binding between your e-commerce system and this other shop providers, so that you have a sync with all your product data. And sometimes they're not so refined that you are doing it in your domain as e-commerce specialist. Another possibility is shared kernels. So everybody wants to do something the same way, so they are using the same domain model here. Good idea is, of course, how you want to define a message in the system. In our terms, it also, like, because with multi-tenants, it needed to include a tenant ID, so we had our own specification how a message should look like. Yeah. for that, you just consume it as a library, for example, here importing via Gradle. Another pattern is like the published language. There, one service gives out a domain model and the others can use it. What we see here is like identifiers within a shop system. So you maybe have an EAN, UPC, ISBN, or NPN product number. So this is also a common pattern between like the two services. And lastly, two services can also decide, of course, to not be connected to each other and not need to hand over any information. What you do normally when you have like knowledge about all these like patterns, you go to your big picture of your architecture and you think about how each service now should be connected to all the other systems. In that case, you also define the team structures and how the teams are communicating. So you are inversing Conway's law, and there should not be any bottlenecks left. So do not apply one pattern like contract and testing everywhere, but think really wisely, okay, how many instances are there of a site service, how many other services need to know about it, and when do they need the information? Do they need it now or like later? And then try to do this modeling with your whole team after the event storming session to a context pattern modeling session. And then try to like do this again we did it like every 3 months, every half year in our architecture COP. To be aware and to reduce the communication amount between the teams, right? Because every time you have a lot of like communication between two teams, this usually is an identification for anti-pattern, and you can solve this really like strategically with the mentoring design. So besides coming up with this structure approach of scaling cloud native architecture, of course, there's a lot of tooling. So cloud native involves not just like building these microservices, but also like having like awareness about like DevOps, continuous delivery, and continuous. And for that reason, you need to agree upon a deployment pipeline. So there's many ways, of course, how you can implement it. A common structure for everybody is always like to have this build stage and have some kind of acceptance stage. In the build stage, you verify that each service works individually. In the acceptance stage, you might spin up, for example, we used a Google Cloud Compute Engine to spin up an environment of all services in the state as they are in production, and then deploy the modified service into that system, then run API tests and the regression test suite again towards it to see if everything works, like in coherence. The next step might be a pre-production stage where you already have a lot of data there. When you are deploying the services, you run a zero downtime test suite against it, like many times, so that you can be sure that your system is really also resilient, and then you go into a production phase. So in terms of this architecture from the e-commerce monolith, over several years we could like have like 3 months releases in the beginning, and in the end it was per team 50 releases per sprint. So it was quite nice to see how the velocity changed and that we come up with a lot of A/B testing for end users. So there's many ways to do that. The industry is helping us a lot. So they founded an institution, the Cloud Native Computing Foundation, and here the overall goal is to empower all organizations to help them working in public and hybrid clouds, especially coming up with all the technology. And the most important part is like the standardization behind them. So yeah, so they're basically like aligning a lot to the definition that we had from the academia already for cloud native applications. And yeah, there's also more definitions from other like companies about cloud native. You can see that I think nearly every like cloud company also has its own definition. Besides that, if you're like in that migration schema where you are not like starting from scratch, there's also a nice idea of a roadmap that was given out by the Cloud Native Computing Foundation. It's sometimes changing, but their idea is always like to come up with containerization first, then implement the ICD, then think about the orchestration. Next, introduce like observability, like tracing and monitoring, maybe with Prometheus. Then have a service discovery, so that each service when it's spin up can be seen within the landscape. Then maybe take care of network policies that you have, like to reduce the workload there. Next, implement distributed elastic data storage, and like it's giving like this nice workflow how you can come up and try like to make an application step by step cloud native ready. Yeah, it's changing fast. It's changing like there's many services or many products that are coming out. So we have this nice cloud native landscape map. And if we are really not sure what we want to use for each section, we can look at the state, and the state is always like also shown within that landscape approach, so like for each project in that landscape, so you can see what's already like a graduated project, so what is like really easy or really stable now to use, what makes maybe sense to introduce as the next step into your landscape, and what is maybe more experimental, just like in an incubating state, right? And this is at least some direction that the Cloud Native Computing Foundation gives out these days. So for me, business and IT these days, they're now the same side of the same coin, and the other side is the market, right? This means for me also like is software eating the world? So in general, I would say large parts are eaten now by software, of course, like Mark Anderson proclaimed it. But what is definitely, in my opinion, not true, not every company needs to become a software company. Some might still rely their core interest in other like industries. There could be, of course, this like disruptionness going on, as I mentioned, like with all that nice cloud native tools that we now have. So you could come up with new business models. So there's many chances. Others that could be added maybe is like Bitcoin here for, it's not like disruptive yet for currencies, but we can think about a lot of stuff that might come up still here, like hidden champions we don't know yet. Yeah, and the good part is like the A lot of stuff is now going open source. It's very stable, and it's ready to use, and it makes a lot of sense to implement it. Yeah, in general, the markets have changed, IT has changed, and we have these new drivers, new goals that we align to, and luckily we got also the new building blocks, and DevOps, DevSecOps, they are now the drivers that we see in IT. If you are interested in the slides, you can grab them here, and then you can also pick up all the reports. They are all linked, and go into detail and inform yourself a bit deeper about all the different principles. And besides that, there's also a nice article. So thanks for your time and attention, and I hope it was interesting. Thank you.